Good afternoon, everyone. Good afternoon.
What's up, guys?
My name's Kelvin, and this
My
is
name's Dylan.
Dylan. We're going to be just doing a little review of Algebra 2, preview of pre-cal, and I'm super excited to go through this material with you. The document we're going to be going through, we'll send it to you in the recap email. So for now, just make sure you have a notebook, calculator, pencil, and just make sure you're taking notes and following along, okay? And I'm not sure, there was some confusion in the previous class. I'm not sure if the school sent you the correct information, so I just want to let you guys know. Class is going to be Tuesday and Thursday, not Tuesday through Thursday, okay? So Tuesday and Thursday, 3 to 4 p.m. Eastern Standard Time, and it'll be this week and next week, okay? So this week, next week, Tuesday and Thursday from 3 to 4 Eastern Standard Time, okay?
Also, guys, if you've been in sessions with us before, you know that we like to have cameras on, all right? So if you guys get a chance, nice, awesome. Let's get some cameras on. All right, they're like more than half of you have them off. Let's go, let's go, let's go. Nice, getting them in. Cool. All right, let's keep it coming. So yeah, this is a relatively small class. Any questions at any point, feel free to shoot Kelvin a DM. And yeah, and also we're going to be calling people, so if you cannot unmute for whatever reason, then let us know. So yeah, I'm just gonna give you guys just another minute so you guys can get a notebook, pencil, calculator, all that good stuff. We're gonna be doing some math problems. The goal for today is just to go over the Anna, you can't unmute. All right, gotcha. So what was I gonna say? Oh yeah. So yeah, the goal today is just to go over some concepts from Algebra 2, stuff that you should get down before we go on to the pre-calc information. Sounds good? All right, got a couple of thumbs up.
Perfect. And if you can't unmute, just go ahead and private message me right now. So Samantha, I got you down. Who else said they cannot unmute? I'll write it down. So anyone who can't unmute for any reason, just let me know. We're going to be calling you guys. So just
Anna Miro can't.
Okay, got it. All right, let's get started.
Cool. Share my screen. It's going to be up in just, oh, wrong thing. It's going to be up in just a second. Hopefully sometime today, if it decides to connect. Likes to keep us in suspense. There you go. Okay, cool. So today we're doing our first session going, oh, let me use a darker pencil. We're doing our first session from Algebra 2 to pre-calc, all right? So today, as we said, today is going to be mostly pre-calc concepts. I mean, mostly Algebra 2 concepts, and we'll get into the Algebra 2 stuff, into the pre-calc later. So let's get someone to read. Beck Gerton, you want to read for us? Oh, Breck, sorry.
What is the value of f of x equals negative 4x to the 5th power plus 6x to the 4th power plus 3x to the 3rd power plus 6x to the 2nd power plus minus 4x plus 12 when x equals negative 1?
All right, that was a mouthful. So with all these, when you have an f of x set function, when you got all these variables of x, just get that value, just get whatever they have for x and plug it into each one of these. Also, key thing to remember, when you're substituting for x, you got to put it in parentheses, right? So you have for this first part, negative 4, and instead of x, we put a parentheses and then negative 1, right, to the 5th power. Now, negative 1 to the 5th power, what's that going to give you? Put it in the chat, we're on mute.
And everyone who said that they can't unmute, I expect you guys to all use the chat, okay? So there's like almost 40 of you, so everyone should be using the chat. Stay engaged as much as possible, okay?
All right. Yeah, come on, guys. There's like almost 40 of you, right? Let's get some more participation. Nice. Cool. Negative 1. Awesome. Yeah. So when you have a negative number to an odd exponent, it's going to stay negative, right? So it's going to give you negative 1. What about negative 1 to the 4th power? What is that going to give you? +1. Perfect. All right. What about this one? What about -1 to the 4th? What's that going to give you? See, a bit more of a mixed bag, right? So this is the power of the parentheses, right? So since the exponent only cares about what's in that parentheses, so this is like saying -1 to the 4th, which is just going to be -1, right? Yeah, so it's going to give you -1. So we care. That's why the parentheses is so important, right? So if it's inside the parentheses, the power affects it. If it's outside, we don't care about it, right? So we put it on after. Cool. So for this question, just plug in numbers, plug in values of x, and that's pretty much it. All right. Can anyone give me the answer? You got your calculators out? Sabrina first out of the gates. Nice. Yep. And choice is B, 29. Cool. Kelvin, who should we call on next?
Sorry. All right. How about Amy? Amy Lopez?
Solve the equation 8x plus 5 equals 45.
Awesome. When they mean solve, what do they mean? What do you want to do?
You have to like isolate the x.
Yeah, perfect. So
yeah.
I cut you off. What are you gonna say?
Yeah, I was gonna say to like you have to find x.
Yeah, exactly. We isolate x. So first, so when isolating, usually we're working off of PEMDAS, right? But when isolating, we got to go backwards. So first we do addition and subtraction, then multiplication and division, then exponents, then parentheses, right? So we're working backwards. So first we're subtracting 5, then 8x is going to be 40, and then you do the multiplication and division, divide by 8, x is going to be 5. All right, cool. Now, y-intercept of the graph, y-intercept is just your y value when x is equal to 0. All right, so how can we find the y-intercept here? Anyone can mute.
Substitute 0 for x.
Yeah, so if you plug in a 0 here, and you plug in a 0 here, what are these first two terms going to be equal to?
0.
Yeah, so this is going to be 0, this is going to be 0, and a y-intercept is going to be 4. All right.
And just remember, right, this is a quadratic written in standard form, right, which is ax squared. Oh, this is actually cubic, but either way, right, that last number is always going to be the y-intercept, right? If the polynomial, if like the power is a number, right, the last number is going to be the y-intercept. Okay.
Awesome. All right, now onto this one. An asteroid travels 400,000 miles in 8 hours. What is the average speed? All right, so here's our biggest hint. Our speed is going to be in miles per hour, miles over hours, right? So how are we going to get our speed? Angelina Fernandez.
We would divide it by like
Divided by what?
By like hours and miles. So like 1 hour. Well, I don't know.
You're good. Yeah. So our speed is going to be our miles over hours, right? So whatever we have for miles, we divide it by whatever we have for hours, right? Let me move this over. So we have what for miles? We have 400,000 thousand. And then we have 8 hours. And that's going to give us an answer. And this is where the calculator comes in. Or maybe you're good at mental math. This will give you 50,000 miles per hour.
And also note, right, anytime you have a slope, right, typically it's going to be change in y per change in x, or for each change in x, or so you want to make sure you get the y over 1, right? Change in y per 1x or per unit x is going to be slope, right?
Yeah.
Good job.
Awesome. Perfect. Yeah. And also when graphing and all that, your time is usually x. All right. So whenever you're dealing with time, you're finding slope, you're finding change, then your time is typically going to be x. It's going to be the denominator of the slope. All right. So let's see.
All right. How about let's get Santiago. Santiago Isaza. Can you read number 6 for us?
Helicopter travels to the east going 160 miles per hour. 3 hours later, it is determined that the helicopter will need to be escorted on its journey to the east. How long will it take an F-14 traveling at 960 miles per hour to catch up with the helicopter?
All right, awesome. So this is all about setting up equations, and this one might be a little bit more difficult, right? So whenever you're dealing with like distance and time and rate and all that, and like rate and all that, your best friend is going to be this equation right here. We like to call it dirt, but it's got a little more value than that. This is an equation that gives you your distance by multiplying your rate by your time. All right. So if you know, you can find distance from rate and time. Cool. So if the F-14 is caught up with the helicopter, that means they traveled the same distance, right? Cool. So that means like they're in the same position, they traveled the same distance. Okay. So we have the distance for the helicopter. It's going to be equal to the rate for the helicopter and the time for the helicopter. And the distance for the F-14 is going to be equal to the rate for the F-14 times the time for the F-14. So these distances are the same. So we can literally just set them equal to each other. So we can just pull one of these here. I'm going to get rid of that, get rid of that. These have to be equal to each other. All right, since these are all equal to the distance and the distance are the same, these are equal to each other. Okay. Now, what is the rate for the helicopter?
Everybody drop in the chat. What is the rate for the helicopter? Remember, if distance equals rate times time, then rate is going to be distance over time, right? Like feet per second, miles per hour, those are all rates. So speed is a rate.
Perfect. Yeah, speed is a rate. Eric, awesome, nailed it. The speed for the helicopter, the rate for the helicopter is 160 miles per hour. All right, so this is going to be 160. Just gonna put MPH. What about the rate for the F-14? I want everyone to put this one. All right, speed for the F-14. Nice. There you go. Awesome. Yeah, rate speed is this is not 900, 960. Perfect. Yeah, so speed is a rate. All right. So now we have the rates we have our two rates. What are we missing? We're missing our time, right? So our time for the what is our time for the helicopter going to be? This is going to be 3 hours, right? Now, our time for the F-14, it started after the helicopter traveled, right? So it's going to be those 3 hours plus however long the F-14 takes. Does that make sense? Cool, because I made a mistake, right? Cool. All right, I messed it up. I mixed it up. So I did this backwards. So let's see. We're multiplying. Okay, so the helicopter travels for 3 hours, right? We know that. All right, I made a mistake in interpreting this. I'm gonna cover my tracks now. So the helicopter travels for 3 hours, right? And then it keeps on going while the F-14 is coming towards the helicopter. So that F-14 is going for some distance X, for some time X. F-14 is traveling for X amount of hours. All right. That helicopter is going the same X amount of hours, but it already ran for 3 hours. Now, do you see where my mistake was? Does that make a little bit more sense?
So one time in the chat, real quick, before the F-14 started, how many hours did the helicopter travel? In the chat, before the F-14 started, how many hours did the helicopter travel? Right, good, right? So a helicopter already travels three hours, right? And helicopter keeps going at a slower speed, right? And then the F-14, which is faster, starts 3 hours later, and so those 3 hours aren't accounted for, right? For the F-14, right? And it travels a certain for a certain amount of time, which we don't know, which is why we call it X. Okay. But as the F-14 is traveling X hours, the helicopter is still traveling that same amount of time. Okay.
Yeah, so if it helps with like a little like visual thing, here is our helicopter. This one's our F-14, right? And then our helicopter got to this point in 3 hours, right? And then it keeps on going. It keeps on going. While it's still going, now the F-14 needs to make up all that time. So this distance that it covered in 3 hours, the F-14 didn't have that. All right. So it got to here, and then it's just like kind of puttering along while the F-14 starts flying towards it. So that's why for the time for the helicopter, it is those original 3 hours plus the time it takes for the F-14 to get there, which is X. All right. So now we have all this here. I'm going to put that there. I'm going to rewrite this equation. So our rate for the F-14 is going to be 960. And we're multiplying by our time, which is X. And then our rate for the helicopter is 160. And then our time for the helicopter is going to be 3 plus X. All right. So we are asked, how long will it take an F-14 to catch up with the helicopter? All right. So what is that asking for? It's asking for how long does the F-14 travel? What variable shows that?
So everyone drop it in the chat.
What part of this question gives us how long the F-14 has been traveling for? There you go, X. All right. So this whole complicated question is just asking us to solve for X. Okay. So how do we do that? First, distribute this 160, right? So there's going to be 960X is equal to, what's this first one going to give us? It's going to be, it's going to give us, wait, yeah. What's this going to give us?
Awesome, right? 480 plus what in the chat? Great, right? Make sure to distribute the 160 to both the 3 and the X, right? Plus 160X. And last step is isolate X, right? So we're going to subtract that 160X on both sides. And then divide. So what do we get, guys? What are we going to get when we subtract 960 minus 160? 800X equals 480. Finally, divide by 800. And what do we get for X, guys, in the chat? X equals awesome, right? You're gonna get some decimal, or if your calculator converts fractions, awesome, right? 3/5. Great job.
Perfect. All right. So this is all about looking at the first part of the question, putting that into equation form, and then keep on going like that, right? So that's the best way to deal with these like really complicated type questions. Okay. So are there any
Perfect.
questions?
Appreciate the thumbs up.
Okay, I think we're
All right. Next up, let's have let me see who we can call on. Sabrina Rivera. Can you read the next question for us? Okay, Sabrina can't unmute. Regina Torres.
A rectangular prism has a volume of 264 cubic inches. The length of the prism is 4 inches. The width is x minus 3 inches and the height is x plus 2 inches. What are the width and the height of the prism?
All
All
right.
right, perfect. Sorry. So real quick in the chat, guys, volume of a rectangular prism, what is the formula for volume in the chat? For a rectangular prism. It's kind of like a cube that's just in the shape of a rectangle. Volume is,
Let me draw it out real quick. It's going to have a base.
And put in the general chat. There we go. All right, good stuff, Christian. Right, length times width times height. Essentially, it's going to be base. The base is just going to be length times width, right? Base times height. So length times width times height. Awesome. Perfect. So Regina, you want to continue walking us through this? So we know the volume is length times width times height, and they give us, right, the volume. So what's the volume going to be?
264.
Awesome. 264 equals, and we're going to say 264 equal to what?
Equals 4 times x minus 3 and times x plus 2.
Perfect, right? So 4 times x minus 3 times x plus 2 equals 264. Perfect. And now we eventually have to solve for what? What's the question mainly asking us to solve for?
For x. Oh, wait.
Almost. We need to eventually solve for x, but what's the goal?
Oh, the width and the height.
The width and the height, which is represented by what? X minus 3 and
X plus 2.
perfect, right? So we got to solve for x either way. So what are you thinking first? Before we can solve for x, what do you have to do? And you could drop it in the chat. Everyone drop it in the chat too. What do you think we should do next?
Do you divide 4?
Perfect, right? Let's get rid of that 4, divide by 4.
On both sides of the equation?
On both sides, great. So we're going to get x minus 3 times x plus 2 equals, what's 264 divided by 4, guys, in the chat? And you all should have your calculator. Perfect, 66. Next step is going to be to FOIL that left side, right? FOIL means first two terms, inner, right? I mean outer, inner, last, right? So first thing, x times x is going to be x squared, right? And Regina, you want to walk us through the rest of that? So it'd be what? X squared.
X squared plus 2x minus 3x minus 6 equals 66.
Awesome. And then what can we do? Remember, whenever we want to solve a quadratic, we got to make sure everything's equal to 0, right? And we should combine like terms as well, right? So what should we do with that 66 on the right side?
Subtract it and put it on the other side.
Good, right? Let's subtract it over, and then let's combine. What's 2x minus 3x? And guys, any question I'm asking, it's put in the chat, right? I know I'm asking Regina, but make sure you guys are using the chat as well. So 2x minus 3x.
Oh, -1.
Perfect, -1x minus x. And then what is -6 minus 66, guys?
-72.
Perfect. Minus 72 all equals 0. And finally, right, in order to solve for x, we got to think of what? Two numbers that multiply to negative 72 and add to negative 1. So always start with what? The multiplication, right? So what two numbers multiply to negative 72 that and add to negative 1 in the chat? What do you guys think? So almost, right? 8 and 9, you're right. 8 times 9 is 72, but it has to be negative, right? Well, one of them has to be negative, right? Two negatives make a positive, right? Negative 8 times negative 9 is positive 72. So one of them has to be negative, one of them has to be positive, and we look at that middle term, the negative x, to determine where the negative should be. So since we know it's going to be negative, that means the bigger number has to be negative, right? So we're going to make the 9 negative, right? So it'd be 8 and negative 9, right? So x plus 8 times x minus 9. Awesome. And then finally, what are the two solutions going to be in the chat? If it's x plus 8, that solution is going to be negative 8. Awesome. And then if it's x minus 9, it's going to be positive 9, right? But which is the only number that we can use, guys, that we can use to represent x logically?
Remember that we are going to plug x back into these equations, right? So this right here, this is our width and this is our height. These are distances. So there's no such thing as a negative distance. There's no such thing as negative 30 miles. All right. So the negative 8 just does not make sense. All right. That's an extraneous solution. Wait, extraneous? Is that no, that's not the right word.
Extraneous?
Extraneous. Yeah, extraneous solution. So our only answer is going to be 9. But again, this is just what x is equal to. The width and height are going to be 9 minus 3 and 9 plus 2. So what's our answer choice, guys? A, B, C, or D?
Guys, the width is going to be 9 minus 3, which is going to be...
What's our answer choice, y'all? A, B, C, or D? Nice. All right. Answer choice A, with the width of 6, 9 minus 3, and a height of 11, which is 9 plus 2. There you go. Awesome. On to the next one. Ooh, absolute values.
Okay,
right.
Next up, let's have Miles Kavanaugh.
You want me to read it?
Yeah, if you can.
Okay. 4p minus 7 equals 3.
Perfect. So forgot one thing. What are those two little brackets around 4p minus 7?
It's absolute value. So like
absolute value. So it's the absolute value of 4p minus 7 equals 3. And Miles, do you feel like you know how to solve absolute value functions?
I think so.
All right, awesome. So whenever you have absolute value, you have to take into account that whatever's in the absolute value can be either positive or negative, right? Because what's the absolute value of 3, Miles?
3.
What's the absolute value of negative 3?
3.
Exactly. So 4p minus 7 can either be what? 3 or?
Negative 3.
Awesome, right? So whenever you have absolute value, you're going to have two solutions, right? So first rule is make sure that the absolute value is equal to a positive number. If it was like the absolute value equals negative 3, automatically no solutions, right? Because absolute value can never be negative, right? But all you do is drop down, right? The first one is going to be 4p minus 7 equals 3. And the second equation is going to be 4p minus 7 equals negative 3, right? So now we're going to use those to solve, right? Subtract 7, right? Both sides. And Miles, what do we get? Oh, my bad, add 7, both sides. And we're going to get what? 4 on the left, we're going to be 4p equals what? 10, and then p equals?
4.
Awesome, right? So 4p equals 10, 4p equals 4, p equals 10 over 4, which is 5/2. And then on the right side?
4p equals 4, so p equals 1.
And p equals 1. Awesome, appreciate it, Miles. Great job. Number 9 is essentially the same concept, right? We're going to set that equal to plus or minus 1. So you could save that for extra practice, right? And let's go ahead and check out number 10. Guys, same deal for number 10, right? If we want to solve for u, we're going to set what? We're going to set 1 plus 3u equal to what in the chat? We're going to set 1 plus 3u equal to? So we have to set it equal to two things. So really good, Sabrina. Negative 6u and 6u, right? And then we solve for u. So we're going to get two solutions for u, okay? Give me a 2 in the chat if you understand absolute values, right? You're going to set whatever's in the absolute value equal to the plus and minus of whatever's on the other side of the equal sign. Give me a 2 in the chat if you get that. Right, so you're going to have two solutions, okay? Awesome.
All right, yeah, so
Uh,
the biggest thing about this is just make one positive, make one negative, and then it's just the algebra, just solve. All right, and you guys can do that part. All right, so let's keep it going. All right, so this is the same deal. They're going to set this guy either positive or negative. We can make them both. You set one positive, one negative, solve for x. All right, same thing, kind of the same deal that we had here. It's just the only thing that's a little tricky is there's a variable on the outside. Nothing much changes. All right, you're still solving for that variable. So
perfect.
yeah.
All right. Let's see who's up. Linda Echeverria, can you read this question for us?
Which cubic function is graphed?
Perfect, right? So if we just look at the answers and try to look at the graph, it'll be really difficult, right? To see, okay, is this that graph? Which is why, right, you just have to understand factors, right? So Dylan, you want to walk us through like how to identify like x-intercepts and how they relate to factors?
All right, awesome. Yeah, so factors, they give you your x-intercepts, right? We've seen factors in a previous question. So all you got to do is when you, let's say for answer choice A, we want to get the solutions, the x-intercepts from answer choice A. That means x, the points where it crosses the y-axis, right? That's going to be +1, -2, and +4, right? Because we're just flipping all these signs. So to test if this is accurate, all we need to know is, does the graph cross at +1, -2, and 4? Is that the case here? Do we see that? Y or N in the chat? Y or N?
So are the x-intercepts 1, -2, and 4 if we're testing A? Yes or no? And look at the graph carefully. The intercepts are where the graph crosses the x-axis, okay? Let's see. Y or N in the chat. We'll wait.
All right, yeah. Awesome. Yeah, so the x-intercepts that we see here in the graph are -4, right? -1 and 2. So if that's what we see here, we need to look for a graph, an equation that has a, let's put it in black, that give us a +4, a +1, and a -2 inside of the inside the parentheses, right? So which one gives us that? Everyone in the chat, all right? I want to see 431 responses, all right? Nice, they're flooding in. Awesome. Thank you, guys. Nice, answer choice B, perfect. So, all right, this is gonna be your answer. There you go. So that's the main thing with these graphs, all right? Now, what about this one? So what is the parent function of the graph? Parent function means what's the base, okay? So the difference is it x squared, x cubed, or x to the power of 4? What shape is this, y'all? What shape are we looking at? What's the name of this?
A parabola.
Yeah, exactly. It's a parabola, right? So parabolas are created by what kind of function? All right, answer choice B. Yeah, it's created by a quadratic. All right, so even though this is not the graph of x squared would be something like, x squared would be like that. So although this is not the graph of x squared, this is a parabola. This is a quadratic. That is what they mean by parent function. All right. So a quadratic is the only function that can make this type of shape. So there you go. What's the next one? Graph of the polynomial. Ooh, this one's a tough one. Who wants to tackle this one?
All right, let's see who can read this for us. How about Chris Martinez? I don't think you're on my list yet. Chris Martinez. How about Angelina? Angelina Fernandez?
What is the graph of the polynomial y equals x cubed plus 3x squared minus 2x minus 1?
Okay, perfect. So, Angelina, if I were to only give you that equation and tell you to graph this on a graph, how do you think do you think you'd be able to graph it? Angelina?
Yes, but we would have to solve it first.
Perfect. You have to solve it, right? Well, here's the good thing, right? Anytime they give you graphs, right? Or anytime you have like an X and a Y, you can simply, right, at least get a couple of points, right? By plugging in values for X to solve for Y, right? So we look at this graph, right? And what's the first thing you notice just by looking at the equation? We talked about this earlier. What number gives us an important piece of information there in that equation? X cubed plus 3x squared minus 2x minus 1. And you could drop in the chat, guys, too, if you see it. What number tells us something about that equation? Cool. So I'm getting a couple of answers, right? So both of them are correct, right? Both the x cubed, x to the third, right, tells us that we're going to have like three changes in directions, right? Or it's going to be an odd function, right? That ends in opposite direction, right? And then the -1, really good job, right? A -1 is going to be what? The y-intercept, right? So we know that y-intercept has to be -1, right? So which one are we going to eliminate right away? Let's look at the answers. Which one does not pass through -1 on the y-axis? Really good, right? So let's get D out of the picture, right? D passes through positive like 5, it looks like, right? And then what's the next easiest number to plug in that we can test? 1. Really good, Christian, right? So let's plug in 1 real quick into that in for x, right? So y equals what? 1 cubed plus 3 times 1 squared minus 2 times 1 minus 1. So that's just going to be what? 1 plus 3 minus 2 minus 1. So what are we going to get? When you plug in 1 for x, what does y equal, guys, in the chat? And I want to see a bunch of answers. If you plug in 1, what do we get for y? Perfect, right? So 1, 1. So look at the graphs. Which ones are we going to eliminate? A, does that pass through 1, 1? Nope. Let's eliminate A, right? C does not pass through 1, 1, right? And we already eliminated D, right? So B, you see how it passes through 1, 1 right there, which means it has to be answer choice B, right? So plugging in numbers is going to be your friend here. We see it's positive, which means it's going to start by going up, right? And then down.
So that's another key technique here. So that x cubed has a lot of power. So you know the parent function x cubed, that gives a function like this, right? This is a positive x cubed, and negative looks like this, where it starts up and it goes down. All right, so these two are negative, so that we know for sure it's not going to be C or D. And then we just have to plug in a point for this one. All right, because these are heading positive, so we know they got at least that going for them. All right, what's the next one? Let's see. Kelvin, why don't you pick someone to tackle this one for us?
Perfect. How about Christian Corte?
Okay, do you want me to read the question?
Yes, thank you.
All right. Which quadrants contain the solutions to the system of inequalities?
All right, perfect. So Christian, when you want to find the solution to a system, so first of all, when you're talking about, if it was two equations, a solution to a system of equations is where they intersect, right? The point of intersection, right? What about a solution when you're talking about a system of inequalities? How would you find the solution? Christian.
Do you solve it the way you would solve two equations in a system of inequalities, and then you shade?
Beautiful. That's it, right? So you basically solve it just like a normal linear equation. You get y by itself, right? In order to graph it, right? And then you shade, right? So Dylan, if you could write down real quick. So if you have like less than or equal to, you're gonna shade what? Up or down?
Down.
Good. You're gonna shade below, right? And if you have greater than or equal to, right? If it's y is greater than or equal to, right? You're going to shade above, right? You're going to shade up, right? Because you want to think of y means up and down, right? So you either shade above or below, okay?
And also
then,
make sure that you're thinking of that like in terms of above and below, not left or right. Okay, make above and below. That's the way to think about it, because we're using if y is greater than or equal to, y is less than or equal to, right? So we're dealing with the y, which is our height. Just this is exactly what Calvin said. I just want to emphasize above or below. That's the mentality we're going for.
and it was kind of, sometimes it'll be kind of tough because it's going to be like it's not going to be too steep. So basically what you want to do is just drop the line horizontal and ask yourself, okay, I'm shading above that line, right? It'll make it a little bit easier. Not left or right, just like Dylan said. So first thing, let's go and look at these equations. First thing we'll do is get y by itself, right? So in the chat, what do you have to do first with that first equation to get y by itself? Drop it in the chat, that first equation. How do you get y by itself? Let's see a bunch of answers. So in this case, we're not going to do like substitution or elimination. We're just going to graph each one and see where the shadings intersect. Perfect, right? So that first equation, if you want to number that top one, number one, Dylan. So that equation right there, right? All we do is you subtract 2x. So on the right, we'll write next to that, subtract 2x will be y is less than or equal to, right? Negative 2x plus 3, right? Give me a 1 in the chat if you understand what we did there. So on that, for equation 1, we just subtracted 2x, and we got on both sides, right? So y is less than or equal to, and you keep the sign, okay? Keep the sign the same. The only time you flip the sign is if you multiply or divide by a negative, okay? If you multiply or divide by negative, the sign flips, okay? And let's look at equation 2, right? To get y by itself, first we're going to subtract x. So, right, you subtract x, and then you have to divide by what in the chat? Subtract x, and then divide by 2, right? Divide by 2, so find that equation. Again, 2 is positive, so the inequality sign does not flip, right? So it'll be y is greater than or equal to negative, right? 1/2 x plus 3 over 2, okay? And then on the right, we can just graph those two equations on a standard xy plane. And first thing we always graph, guys, is what? The y-intercept, right? So for equation 1, just graph that 3 right there, plus 3. And it doesn't have to look pretty. It'll be pretty obvious once you graph it, right? And then we're going what? Negative 2 means negative, the slope is negative 2 over 1. So we're going down 2 over 1, right? So down 2 over 1. Perfect, right? And solid line is for greater than or equal to or less than or equal to. If it was just greater than or less than, it would be a dashed line, right? And then, guys, are we shading above or below? A or B in the chat? A or B, above or below that line? That line that Dylan just drew, are we going to shade above it or below it? A or B? And here's a tip. Just look at y, right? Y is less than or equal to. So if it's y is less than, that means all the y values have to be less than, right? Which means we know we're going to shade under that, right? Under the line. So technically, right, it would be like that left side, but do you guys see how that's under the line, right? That's below the line. Awesome. Cool. So always shade first. I would shade really lightly just so you can see where they intersect, right? Just like Dylan did. So the next graph is y is greater than or equal to 1/3 x plus 3/2. So first thing, graph that y-intercept at 3/2, which is going to be a little bit above 1, right between 1 and 2. And then it's -1/2. So we're going to go down 1/2, right? And it looks something like that. And guys, A or B, are we shading above or below that graph? I mean, that line right there. Good. Y is greater than means we're shading above, right? So above means like up. So that negative line, we're going to shade above that negative line. Now, this is where you got to be really careful, right? The solutions are where they intersect, right? So if you guys remember your quadrants, right? It starts at top right, it's quadrant 1, right? That one's quadrant 1, and then 2 going counterclockwise, right? 1, 2, 3, 4. So look really carefully, guys. Which quadrants contain solutions? And put in the chat which 2 quadrants, or which one, whatever you think. Which ones have solutions? So I see a lot of you see it's 2, right? So 2 definitely has solutions, but how about 1? Remember, the quadrant is basically that that 1/4, right? You see where the green lines are? That top right. So there's some shading, right, in quadrant 1 as well, where Dylan's pointing, right? So definitely 2 and some in 1 as well. Quadrant 3, however, guys, does it intersect in both in quadrant 3, or is it just one of the equations? All right. That would only be the first equation, right? So remember, the solution is where the shadings intersect. Okay, so just quadrant 1 and 2. So what would the answer be in the chat, guys? Amazing job. Let's go ahead and skip number 17 again. We'll send you this. Skip number 17. Number 18, also more inequalities, right? Just make sure you remember how inequalities work. So just practice those signs, right? And go to office hours if you have any extra questions. Let's go ahead and practice number 19, right? What is the solution to the system of equations, okay? This is definitely really important that you're able to solve systems, okay? So let's see. Whenever you're solving a system, right, you want to think substitution or elimination, okay? Substitution or elimination. And you always want to try to pick the method that gets you the answer most effectively, right? So let's go ahead and read this question. How about Natalie Acebo? Natalie Acebo? Can you read the question for me?
Sorry, the button for unmuting was like being weird.
You're good, Dor.
Okay, what is the solution to this system of equations? 2x plus y minus 3 equals 0. 2x minus 3y plus 1 equals 0.
Perfect, right? So first thing you want to look at is the equations. What kind of equations are we looking at, Natalie?
We're looking at, what are they called again? Standard? It was something with standard in there.
They're almost a standard form, right? So are they linear, quadratic, exponential? What are they?
Linear.
Linear, awesome, right? Because x is being raised to the first power, right? So these are linear equations. And do you remember the 2 methods when you're dealing with systems of solving?
No.
Okay, so we can either substitute or eliminate, okay? So when we substitute, we're going to isolate one of the variables in one equation. So basically just solve for one variable in one equation. And then we're going to have that value that we can plug into to the other equation, okay? So that's substitution. Elimination is when we basically multiply one or both equations by a certain number that gets us the same coefficient but opposite signs, so that when we add the equations, one of the variables basically disappears, right, or cancels out.
Yeah.
Cool. So let's look at these equations. Either method works, right? Typically, if y or x is already by itself, substitution can be a pretty good option, right? So do you see x or y by itself in any of the equations, like with a coefficient of 1?
Yeah,
Which equation?
the first one.
The first one, right? So if we want to get y by itself in that first one, what would it be? How would we do that?
We would have to divide the bottom by 3.
So let's not even look at the second equation, right? I know. Oh, okay. So you're talking about elimination, right?
Yeah.
If we want to, okay. So Amy, and both of you are talking about elimination. So it seems like you guys understand how elimination would work, but let's practice substitution, right?
Okay.
The only thing about elimination is if we divide the bottom by 3, we're going to end up with fractions, right? We don't like fractions on this test. You see how if we divide that by 3, we'd end up with a fraction, right?
Yeah.
But Amy said we can multiply that top one by 3, right, to eliminate y. That would work, right? But let's practice substitution right now, okay?
Okay.
So to substitute, you just get y by itself in just that first equation, right? So to get y by itself in just the first equation, let's write that down, right? 2x plus y equal minus 3 equals 0. What would we do first to get y by itself?
We would move the 2x.
Good, right? So let's subtract the 2x to that side, to the other side, and we would also do what?
We would also move the minus 3.
Awesome, by adding, right? So add the 3 to both sides. So we have y equals negative 2x, right? Plus 3.
Mm-hmm.
So
Yeah.
that's the first step. First is isolate one variable in one equation, and then we plug that value into which equation?
We plug it into the second one.
Perfect, right? So we have 2x minus 3. And now what does y equal? What do we know y equals?
Y equals minus 2x plus 3.
Perfect. So we can just substitute negative 2x plus 3.
Yeah.
And then also don't forget what's the rest of that equation? Plus 1, right?
Yeah. Plus 1
equals
equals
0. And now finally we can solve for x, right? So remember, guys, if you want to solve for x, you solve for y. You solve for y and then substitute for y. If you want to solve for y, you solve for x and then substitute for x, right? So let's go ahead and distribute. We're going to have 2x. What's negative 3 times negative 2x?
Negative 6x.
Almost. Negative 3 times, so negative times negative.
Oh, 6x.
Perfect, right? Plus 6x. And then negative 3 times positive 3?
Negative 9.
Awesome, minus 9. And then don't forget the plus 1, right? Equals 0. Yeah. And then we're going to have 2x plus 6x is?
8x.
8x. And let's go ahead and move the numbers to the other side, right? So let's add. So what is negative 9 plus 1?
Negative 8.
Good. Minus 8 equals 0. And then finally, let's add that 8 over, right? And then we're going to have 8x equals 8. So what does x equal?
1.
X equals 1. Perfect. And let's look at the answers, right? So unfortunately, right, we can eliminate 2 answers. We'll eliminate B and D, but we have 2 answers where x is 1. So once you solve for x, how do you solve for y?
You do the same thing, but instead of doing what we first did with the y, you do it with the x.
Even easier. Once you have x, all you do is
plug it in.
That's it, right? Just plug it in, right? So, and does it matter which equation you plug it into?
Plug it into the first one.
Cool. It doesn't matter though, right? You can plug it into either equation. I plug it into the easier one. I think the first one you're right is much easier, right? Because y is already by itself. Great job. So it'll be 2x plus y minus 3 equals 0. And then we just can plug in 1 for x, right? So it'd be 2 times 1, right? Plus y minus 3 equals 0, right? And then let's just go ahead and combine 2 minus 3 is negative 1, right?
Yeah.
Add 1 to both sides, y equals 1. That's it, right? So perfect. Answer is A. Natalie, appreciate you. Great job.
Thank you.
And that's it, right? So make sure you know how to do substitution. Dylan, do you want to add anything?
Yeah, I just wanted to briefly go over elimination. All right, so cool.
Perfect.
Substitution. What we did first is first we solved for y, we plugged it in, then we solved for x, and then we plugged that in and we got our number for y, right? So that was substitution. The thing is, elimination sometimes helps us save some time. So let me grab all of this, move it out of the way, put it down here. Now, elimination is all about adding the equations together. So that is really useful whenever you have the two equations and you see something line up like this. You have 2x and 2x. Those line up. So if you make, let's say, this one, make this whole equation, make that negative. Now you're going to get, and I'm rewriting the two equations, 2x plus y minus 3 is equal to 0. And you have negative 2x plus 3y minus 1 is equal to 0. If you just add these together, the 2x's cancel. And then you add these two together, you're going to get 4y. Add these two together, you're going to get negative 4 is equal to 0. And then you add 4, 4y is equal to 4 divided by 4. Y is equal to 1. Okay, and you know that y is equal to 1, and it brings you down these two choices. And then from here, you can just plug it into the other equation to get your value of x. So you get the same result as substitution. It's just that elimination is easier if the terms already line up like this. That way you can go ahead and cancel things out quickly. So either one works, whichever you're most comfortable with. I recommend getting comfortable with elimination because it does let you save a lot of time with certain questions.
100% agree. Yeah. I usually try to, if I can eliminate, I'm going to eliminate just because it's going to be faster usually, right? So in this question in particular, right, elimination was the faster method.
Yeah.
So make sure you're good at both. Ask yourself which method will get me the answer more effectively. Okay.
Awesome. So do we do another question or?
I say let's cut it there, right? We have one more minute. So great session, guys. We're gonna make sure to send you this packet. We're gonna figure out if we should assign maybe the rest of the packet for you to look over on your own, because we have a bunch of like material to go over, right? So the next few concepts are like matrices, imaginary numbers, stuff like that. So we'll make sure to send you everything. But I hope today's session was helpful. And yeah, it was meant to be a preview of what you did last year and a review. So next session is on Thursday, right? Thursday, 3 to 4 p.m. Eastern Standard Time. And then next week we'll have 2 more sessions, right? So right now it's more of a preview, and then I think next week will be more of like a review for what you're about to learn next year, okay? And yeah, hope you all have a good one. Thank you so much for joining.
Have a good day, y'all. See ya.